Now let's start working on task 2. We're given another integral here and the number of segments that we're supposed to use is 4. So first we'll compute an approximation of I using multiple segment trapezoidal rule, and then we'll compute the absolute relative true error. So our integral given to us is from 2 to 3, 1 over x plus 1 dx, and the number of segments that we have is 4. So we have 4 segments that will work for the multiple trapezoidal rule here. So this is an example or a task we have to solve with multiple segment trapezoidal rule, and the formula for the multiple segment trapezoidal rule is, if you're given a function, a definite function from a to b to be integrated, we will have the formula as this here. So b minus a over 2n times f of a plus 2 times the summation from I is equal to 1 until n minus 1 of f of a plus ih, bracket closed, plus f of b. So now if we replace this with our details, so we have our b is 3 minus a is 2 divided by 2 times segments is 4, and then we have f of a is 2 plus 2 times the summation going from I is equal to 1 until n minus 1. So n is 4, therefore n minus 1 is 3. F of a is 2 plus I times h is, okay, we have to calculate the value of h now. So as we know, h is b minus a over n. So here we have our b is 3 minus 2 over n is 4. So that is equal to 1 over 4, which is 0.25. Now here h is 0.25 plus f of b, that's 3. Now here this is 3 minus 2 is 1 over 4 times 2 is 8, and here we have f of 2 plus 2 times f of 2 plus I is equal to 1 at first times 0.25, and then we have plus f of 2 plus I is equal to 2 now times 0.25 plus f of, let's write it here, f of 2 plus I is equal to 3 now times 0.25 plus, so here we are done with the 3 iterations, and then we have f of 3. So now this is equal to 1 over 8 times 0.3333 plus 2 times 0.3077 plus 0.2857 plus 0.2667, bracket closed, plus the last value f of 3, which is 0.25. So that calculated, we'll get the answer as 0.25. 2879375. So that's the approximated value of the given integral using multiple segment trapezoidal rule. Now the second part of the question asked us to find out the absolute relative true error. So for that we need to first find out the exact value of the integral. So we have to integrate from 2 to 3, 1 over x plus 1 dx, and let us say that u is equal to x plus 1. So du by dx will have 1, and then we can take this dx to the other side. So we can say that du is 1 times dx, which is dx. Now if we integrate 1 over u, so x plus 1 we replace by u, this will be equal to, then we will replace the dx here, as we say dx is equal to du, so we'll replace it by du here now. So this is equal to ln u, and now we can replace the u with x plus 1, and finally we can say that it is ln of x plus 1 plus c. So that's the answer of the integration. And now if we try to integrate it between the interval, so we'll have ln x plus 1 to be integrated between the interval 2 to 3. So that will be ln of x plus 1, so 2 plus 1 is 3, minus, first we'll do 3 plus 1, 4. So 4 minus ln 2 plus 1, 3. And that gives us the exact solution now, which is 0.2876820720725. So now we have our exact solution and we have our approximated solution, so we can find out the absolute relative true error, which is true error, so that will be 0.28768200725 minus the approximated value was 0.2879375, and the whole thing divided by the original value, which is 0.28768200725 times 100, and this gives us a relative error of 0.0888%. So that's the end of the solution.